Acute coronary syndrome, or a cardiac ischemic event, can cause ST segment elevation or depression on the ECG. But have you ever wondered why these ECG changes happen? Let's talk about it. In order to understand why ST segment elevation and depression happen, we must first have an understanding of cardiac myocytes and cardiac cells action potential, which consists of 5 different steps. Step 4, or the resting state. Step 0, or depolarization. Step 1, also known as the notch, is early repolarization. Step 2 is plateau. Step 3 is late repolarization, and then back to 4 again, which is our resting state. Now it's important to remember step 4 correlates to the isoelectric line where there is no electrical activity when we talk about the relationship between membrane potential and ECG tracing. If we were to imagine a myocyte during the resting state, there is potassium inside the cell and sodium and calcium outside of the cell. Now, at rest, inside of the cell is more negative. So right here at 4, inside of the cell is negative 90 millivolts. Now, anything that can cause the inside of the cell to suddenly become more positive is going to cause cardiac cell depolarization. In normal circumstances, the way this occurs is that sodium channels open and sodium pours inside of the cell. And this causes the inside of the cell to become more positive, and we call that cardiac cell depolarization. Once cardiac cells have depolarized, the sodium channels close and the potassium channels open. So potassium starts pouring out of the cell to make the inside of the cell again more negative in preparation to return back to the resting state. And this will give us our notch or our early repolarization. At the same time, calcium channels open, and calcium, which is responsible for cardiac cells contraction, enters the cell. Once the calcium entering the cell matches the potassium exiting the cell, we get our plateau. Once we've had our cardiac cells contraction, potassium continues to pour out of the cell and makes the inside of the cell more negative again till we get to our negative 90 millivolts. Now, what's important to remember here is that when we talk about these, for example, the sodium channels or the calcium channels or the potassium channels, for your myocytes to control these channels, it is an active process. And when we talk about an active process, we're talking about a process where the cells must spend ATP to achieve what they need to do. Now, in a case of a cardiac ischemic event where there is a lack of oxygen, there is a lack of ATP. So your cardiac cells would not have the control they would normally have over these channels. Once again, a quick reminder. Anytime a signal travels towards a positive lead, you will get a positive deflection on your ECG paper. And anytime it travels away from a positive lead, you get a negative deflection on your ECG paper, right? So let's say you have a positive lead that's looking at this region of your ventricular wall, and you have an area of subendocardial ischemia. Let's say the ischemia is in this region right there. Now, what happens with the cells in this area is that because of the lack of ATP, the potassium channels open, and potassium prematurely starts pouring out of the cell. Remember, anything that causes the inside of the cell to become more positive is going to cause cardiac cell depolarization. So what happens is that in this case, you will have early depolarization, premature depolarization of these cardiac cells. Now, as you recall, when we talk about the cardiac cell's action potential, step 4, which correlates with our isoelectric line, is at negative 90 millivolts. Now, if something happened, or if the cardiac cell was ischemic and it started to leak potassium out prematurely, and the inside of the cell became more positive prematurely. The beginning of your QRS complex, or the stage 4, might start more positive than it would normally, let's say negative 50 millivolts. So what this does is that it brings up the beginning of your QRS complex. Now, once the rest of the ventricle depolarizes, everything goes back to normal, to where it should have been, which was negative 90 millivolts. So what happens here is that, let's say you have these cardiac cells right here that are becoming prematurely more positive. Well, they're going to prematurely depolarize the cardiac cells that are around them. Because this early depolarization occurs towards a positive lead, what you will end up with is a QRS complex where the isoelectric line starts more positive, then you will have your QRS complex, and then your ST segment goes back to where it should have been originally. And for this reason, subendocardial ischemia causes ST segment depression, when in reality, all that happened was the beginning of your QRS complex was elevated. Now, in the case of transmural ischemia, where the entire full thickness of the muscle is involved, the same exact premature depolarization occurs, but it can only happen away from our positive lead towards the healthy cells. And because this occurs away from a positive lead, what ends up happening is that the beginning of the QRS complex is actually depressed. The rest of the QRS happens, and the ST segment goes back to where it originally should have been. And so what happens is that on your ECG tracing, this will give you the appearance of ST segment elevation.